Welcome back to the course on programming paradigms. In this video, we will be discussing about coroutine. A coroutine is actually a routine that can be suspended at some point and resume from that point when the control returns. It has got multiple entry points. Only one coroutine can execute at a time. Basically, a coroutine is actually a subprogram that has got multiple entries, multiple pathways, and controls them itself. A coroutine call is done using resume. So the difference between coroutine and subroutine is that when you call a subroutine, that particular subroutine will start its execution and return back to the caller only when its execution is completed. And when the subroutine returns after completing its execution, the caller will continue its execution. But in the case of coroutine, if we call as coroutine, the called coroutine can start executing from its first location and continue to execute. And before it finishes its execution, it can go back to the caller, and in the caller, it can resume its execution, and the caller can again call the same coroutine, and the coroutine will resume its execution instead of starting from the first location. So that is the difference between coroutine and subroutine. So this is the example. You have two coroutines A and B. A starts its execution and A reaches this point, so it calls the coroutine B, so it is calling resume B. So this is the first instance of calling B, so it will start from the first location. B executes for a few statements, then it calls A. So when it calls A, you can see that the control goes back to this location. It does not go to the first location. If it was a subroutine, the control will be going to the first location. But since this is a coroutine, the control is going to this particular location. Then from there, it executes again and it again calls resume B. So when it calls resume B, it is coming back to this location instead of going to the first location. So from there, B is executed till here. From there, again A is resumed. Then it executes like this. Then from here, again B is resumed. Then it comes like this. So that is your coroutine. So if you have an iteration, what happens is I will start executing from here to here. Then I am calling resume B. So the first resume will go to the first location. Then it will execute like this till here. Then it is calling resume A. So when it calls resume A, the control goes from here to this location instead of the first location. Then it will execute till the end of the loop, then come back to the first statement, execute till here, then again it calls resume B. So since this is the second resume B, the subsequent all the subsequent resumes will be from this location, not the first location. So that is a coroutine. Coroutine helps in execution of programs in a concurrent fashion. Coroutines are implemented using something called as cactus stack. You cannot use a simple stack because the coroutine calls and returns does not occur in last in first out order. Instead, at the same time, two coroutines must coexist. So you have to implement it using some sharing mechanism which is called as cactus stack. So a cactus stack is a data structure for storing activation records where the lexical clusters have unlimited extent. It is basically a stack with branches. Whenever a long lasting closure is created, a new stack is created for its execution. The topmost activation record on this closure stack has its static chain pointer pointing to the context it was created in. Whenever the closure goes away, its corresponding branch is deleted. The portions of the original stack above the branch point are only released when all the branches are no longer in use. So what happens is whenever you call or create a coroutine, you create a new branch. So in this case, can see that you have a coroutine A, M, and Q. M is the main coroutine. M calls the coroutine B and S, and B calls the coroutine D. So M is the main routine. Calls or creates B, so it is branched here. Then B and S are in the same level, so they are stacked on one on top of each other. And B creates D. The static chains are from the created coroutines to its caller. So B is created by M, so there's a static chain here. S is also created by M, so there's a static chain here. D is created by B, there's a static chain here.